Hello, my name is Yishai. I'm the CTO for LinearB, and I'm going to talk about optimizing non-coding time. So, quick history of software development. Way back, we had waterfall, giant design cycles, PRDs, lots of documentations, release a new version every 2 years or maybe a year, maybe 9 months. We still have very large cloud companies, SaaS vendors that have quarterly releases. And the main pain with waterfall was that while you were designing and while you were building this huge release, the world continued to move. You would land very far from where you wanted to be. And you would have an immensely long learning cycle to improve anything about what you're coding. Then came Agile. And we had sprints and story points and stand-ups and religious wars about what it means to be agile. And finally, DevOps came into the world with the movement to the public cloud, the ability to spin up resources and infrastructure as code. And basically, a lot of, once my code is ready, there is a pretty automated way to get my code wrapped up, built, tested, eventually deployed if I'm fully CI/CD'd. My code changes can make it to production and impact the world and give me some learning back pretty rapidly. So this shift has enabled us as developers to move much faster, to learn faster, and to iterate in a meaningful way with feedback from the world, from our users. But there's still a lot going on that needs to be improved. That's what I'm going to focus on. So as an industry, a lot of effort has gone into and is still going into optimizing my coding work. Think about Copilot and other great projects that help me code faster, code better. Lots of investments into IDEs and in testing environments and libraries, even the shift left for security and for infrastructure. These are all things that help me improve my production capabilities while I'm writing code. But what about the other bucket? And if I'm looking at a specific day or a typical day, I'm lucky as a developer if I get 2 hours of coding, real coding in the zone on a given day. The rest of my day is about meetings, is about housekeeping, is about some planning and agile work. A lot of the time is about reviews and helping make sure that the code quality of everything coming in is actually up to par. And I'm going to talk about how we optimize the second bucket, the part that is, I would say, underserved in the breadth of tools and investments that I get as a developer. There's a nice quote here. I'm not going to read everything. Arnis, CEO, talking about developer toil. And what caught my eye is that he's not talking about this is hampering my company's progress or ruining my day as a developer. It's about impacting the pace at which humanity can progress. Everything is software today. Software is eating the world. And for humanity to progress at a clip pace, we need to remove developer toil. So that's a pretty fresh perspective and helps us all feel important. It's not about our code, it's about humanity. So, a typical day in the life of a developer. I just solved a bug that was killing users in production. I just finished this great feature where I made some small but important changes. Great, I'm ready. Now I have to wait for 6 days for someone to review my code and eventually get this pull request merged. This may sound a lot, but we have data to show that this is pretty typical. People wait days, sometimes weeks, for their code to get reviewed and merged. It's a tedious cycle, and it has lots of implications on our ability to push our changes and impact the world. So, pull requests. Raise your hand if you're using pull requests in your day-to-day work. Clap if you hate pull requests. Yeah, so we're getting a very emotional feedbacks on the notion of pull requests. Can't live with them, can't live without them. People feel they're slowing us down. We have to wait a lot for people to review our code. On the other hand, pull requests are a great tool for finding those stupid bugs or keeping the code quality up. They're a great tool for onboarding new people to the team and to the code base. The world needs more and more developers. Most of them are going to be junior by definition. If we're doubling or tripling the number of developers in the world, they will be juniors in the next few years, and this is not changing because the growth is continuing. So pull requests are here to stay, and they're pretty much the standard for almost all organizations that write code for money. I'm going to dive into some data that we found in LinearB in our labs, researching around 1 million pull requests from about 25,000 developers, looking at what's the process, what's going on with these pull requests. And we found that if you look at the life cycle of a piece of work in my code, beginning with coding, from my first commit, as I write the code, shape it up, make sure it's working for me, which is a great milestone. Eventually, I start the PR, then pickup tells me how long I'm waiting for someone to begin reviewing my code. Review process, which takes days on average, is whatever needs to happen for the code to get merged. Finalize the review, get acceptance, and merge it. And then deploy is from the code base to production. And we found that the pull request cycle, the code review cycle, the middle part, is what's killing productivity and creating this huge delay. We took a deeper look, and we found that if you look at specific PRs, they're idle for most of their time. And when I'm saying idle, I mean swapped out. No one's working on them. They're not in anyone's memory or recent memory, just waiting. So 50% of the PRs, half of your PRs, are going to be idle for half the time they're alive. And a third of them are going to be idle for almost 80% of the time they're alive, from create PR to merge. This is after discounting nights and weekends. This is actual work time that could be spent on promoting those PRs, but they're just waiting. It's not saying that developers are idle. They are working on other things. But the PR gets very little work compared to the time it's actually alive. So what is causing the problem? What is causing us, in general, to be inefficient with how we work with PRs and how we get our code from ready to merge to production? We broke this down to 3 problem areas. One is awareness. We, as a team, as a dev team, are not aware of what's waiting for me to review, what's in the queue, what's the status of each PR. It's very hard for us to keep tabs on these things as they move between people and between stages. So awareness makes it difficult for us, or lack of awareness makes it difficult for us to do the right thing at the right time and push things forward. Second thing is context. When someone creates a PR and assigns it to me, maybe I get some alert from GitHub, maybe they Slack me. Way back before COVID, they would actually spin it in the chair and holler and say, there's a PR waiting, can you take a look? But that's all the context I have. I have this PR for a bug fix, can you take a look? I have no context about what this really is about. Is the kind of priority, the kind of effort that I'm expected to get to be required to review here. So I click, and then I get this wall of green and red, and click back. And I don't have time for this right now. So no context leads to bad decisions, like what to do when. And finally, automation. PRs are unique. Each one does a different thing. This could be a very small documentation change. This could be a huge factor. But they're all treated in the same way. We need 4 eyes. We need someone to take a look. We have pretty typically a uniform process for all these PRs. So automation is a way to address this, and I'll describe that. So a couple of examples of how tooling can help with awareness and context. WorkerBee is our smart bot, LinearB smart bot for developers. But there are, I've seen other tools approaching the same problems. On the left, you see an example where the alert about a pull request waiting for you now has additional context. For example, estimated review time is a bit small, but if you can see, our model will predict how long this is going to take you to review this pull request. So now, if this is a 2 to 5 minute thing, I can do this between meetings or maybe in a meeting. If this is a 30 to 60 minute PR, I need to allocate some time. I get better context, I can make better decisions. What's the related JIRA issue? All of these small pieces of context help me make the right decision. And additional helper to move things fast, if the PR is very small, this is like a 2-liner, the alert will actually have snippet, the actual diff inside in a one-click approve button. So I have the full context. I can see everything. I can just make a decision, approve it, or go to review it, and I'm done. So small things that help us with awareness, with context, and with moving fast. And results show that pickup time, the time from when a PR was created until it got the first review or the first comment, can be slashed from days to hours and more. So everything is fresh, the context switches are less painful, everything moves on faster, you get less idle time, and the entire team is happy. So yeah, we talked about pull requests all looking alike on the surface. And until you open the pull request, you don't know, is this a 5-minute pull request? Is this a 4-hour one? What's happening inside? What is it touching? And these all are things that should drive my decisions about how to review, how to address the pull request. So if we look at the CI/CD approach, where you have CI dealing with testing and building and creating assurance that everything is ready for deployment, and then CD doing the actual deploy. Let's add continuous merge into this equation and think about how do we treat the code to PR to merge cycle as a continuous and programmatic thing. So we can automate in places, pull in the humans where needed, and complete the continuous something to basically cover our entire pipeline. So Gitstream is our approach for doing this, and basically move from every pull request gets the same treatment to now you can do continuous merge, and you can use rules to decide about things that get auto-approved, maybe even auto-merged, maybe merge and then tell the team. So ship, show, ask model. If you want to, in some cases, merge the PR, move on, but let the team know if someone needs to take a look post-merge. If it's a pretty common PR, common middle ground, then yes, you need a reviewer, and Gitstream can help you with finding the best reviewer, and with even managing what happens when that reviewer is not available or is not responsive and so on. And if it's a complex change and you define what that means for your team in your repo, then maybe you need to pull in two reviewers or pull in a specific person. So think about code owners on steroids, but also the ability to have flexibility in deciding is this a one reviewer process? Is this at least 2 people? One of them should be ABC, or anything else you can imagine. The setup or the rules that you set up as a team for your repo are basically managed in a .cm file in your repo, similar to how you think about GitHub Actions. And you can decide what is the rules or the thresholds. This could be about PR size, about the kinds of files or specific files being touched. We have people using this to automatically request changes if you are using a deprecated API. So you can attach this to tests, you can attach this to smart things like the estimated review time. All of these are inputs to make a decision about what should be the review process. And our LinearB Labs data show that between 20 and 40% of PRs in a given organization are approved with an LGTM comment. Okay, you're not saying, no information provided except this looks good. So at least some of these are great candidates for automatic approval. You're already rubber stamping these. Let's make it official. Let's give it a name. And once you've carved out all these small PRs, maybe documentation, configuration changes, maybe changes to static files or assets, each team has its own rule set. You move those away. You've now made time for the reviewers to focus on the real PRs, the real ones that matter, where your risk is, where you need to additional eyes, maybe four, et cetera. So, the options are endless. You could be about looking for PII. You could be integrating something like time to live. So a PR is waiting for review, but if nothing happens, it gets merged after 2 hours. No one starts the review. All these flows make it very easy for the team to really decide and codify their process, which today is pretty much oral lore. This is how we do things. Now it's in the code, and you managed inversions like anything else. And the results are typically to slash down on the review cycle. Instead of days, you can go down to hours, or instead of waiting for a week for the PR to get there, you can get down to a day. Yeah, so the same developer made a change, fixed some small things, auto-approve, I can move on next. And we found that developers are happy when the pipeline is happy. Developers want to produce. And developers, one of the things that they hate are context switches and being stuck. Waiting for someone else to review my code, which might be needed, but if this is happening in hours instead of days or in days instead of weeks, developers are happy. Developer experience goes through the roof. So I'm Yishai. Happy to get your questions here or on email. You can easily find me on Twitter as well. And you can check out Gitstream. There's an idea about how to address this, how to put this in your repos, and start automating those pull requests and optimizing your non-coding time.